What's good, my fellow GeoGeeks and MetaMappers? Spatial Ninja here, bringing you this next episode of MetaMapping. And in today's episode, we're going to talk about Web3. So let's get it. Now, there's a lot of terminology commonly associated with Web3. So let's play a little buzzword bingo and start to define some of these terms, and then talk a little bit about how they may apply to the GIS or geospatial world. Now, for today's episode, the terms that we are going to cover on our bingo card are Web3, blockchain, proof of work, proof of stake, and smart contracts. We'll cover the other terms on a follow-on episode. But let's jump right into our first term, which is Web3. Now, before we really dive into what Web3 is, it's probably good to talk about what Web 1 and Web 2 are. So Web 1 you can think of as that first iteration of the internet. It was these static web pages with producers producing some of those web pages and mainly just consumption of that content. This version of the internet was really referred to as that read-only version because there were mainly consumers and only a few producers of content. Then we had Web 2. This is really where we started to see the emergence of social media platforms. And with this platform-based internet, you now had far more producers than consumers. So if we think about social media, having the ability to share a status update, post a photo, post a video, you are now producing content very easily and pushing that into the internet. And others are now able to very easily consume that content. So this version of the internet is commonly referred to as the read-write era. And this is where we are today. Now let's jump to Web 3. So this is the future of the internet. We're starting to get there, and we will get there in the coming years. Now, Web3 really builds on those concepts around Web 2 and that platform-first approach. But what Web3 does is it really starts to decentralize the underlying internet backbone and infrastructure, as well as allows people to take more ownership over the content and internet. Right? If we think about who really owns the content and the underlying infrastructure, it's just a few companies. It's Amazon, it's Google, it's Microsoft, it's Facebook, Meta, right? Just a few companies really own the internet and all that content. So the promise of Web3 is to decentralize more of the actual underlying infrastructure, but also put the rights to data and content ownership back into the hands of the people and those that are actually producing content and publishing it and sharing it to the internet. Now, there are some new technologies that are really going to power Web 3. One of those is called blockchain. You hear blockchain a lot when you talk about cryptocurrencies and things like Bitcoin, but let's talk about what blockchain actually is and how this is really going to support these ideas of Web3. So what a blockchain is essentially just a distributed ledger, a way to keep records that is a database that is shared across multiple nodes within a computerized network. So I like to think of a blockchain as a spreadsheet or Excel on steroids. So instead of one single spreadsheet with all of these historical transactions or records, you can now distribute that out across multiple spreadsheets. Those spreadsheets are also unable to be corrupted because they are backed up and duplicated across a large computer network. So the main use case for blockchain originally was Bitcoin. So this was a way to keep track of financial records and allow for trading and exchanging currency without the need for a middleman like a bank. So if I wanted to send money, or in this case, cryptocurrency like Bitcoin, to somebody, that transactional record is maintained and stored on the blockchain. And that record knows how much Bitcoin I have or how much Bitcoin somebody else has. So it reduces the need for having that middleman bank to handle those transactions and to keep all of those historical records. But the real value here of the blockchain is that it allows for immediate, shared, and secured and completely transparent access to all of these transactions that are made to this network. But how does a blockchain actually work in practice? So if we again take that concept, idea, or use case around Bitcoin, and we make a transaction leveraging Bitcoin. Essentially, that transaction is spread out across a variety of nodes in a peer-to-peer network. And all of those then nodes get together and start to work to validate that transaction. Now, they look at the blockchain, they look at prior transactions, and if they agree that this transaction can take place, then one of those nodes then creates a new block within that blockchain, which becomes that historical record within that chain of blocks. Once that occurs, that transaction is complete, and that transaction is then stored and maintained on the blockchain for its entirety. Now, this process to validate these transactions, enter these new blocks on the blockchain, there are two main concepts or ways that this happens. And these are called consensus mechanisms. So when the network has consensus and is able to validate the transaction. So the first consensus mechanism is proof of work, and the second is proof of stake. So these will be the two next terms on our bingo card that we talk about. So what is proof of work? Well, proof of work is when a transaction is made to a blockchain network that leverages proof of work, a transaction fee occurs. So you are charged a fee for submitting a transaction to the network. If you're using the Ethereum network, which is a proof of work network today, it's called a gas fee. And what happens is you've got all these different nodes, or what they call miners, in the network that essentially compete to solve these mathematical problems. Now, the node that can solve these problems the quickest with the highest efficiency gets chosen as the node that then validates the network, creates that new block, and enters it into the blockchain. So all these computers are competing against each other. And the one that is chosen is then rewarded with a block reward or cryptocurrency. So this is commonly called mining, where you are rewarded cryptocurrency for mining or for validating that proof of work network. Now, there's a lot of negative connotations with proof of work because all these computers are competing, and the amount of processing needed to solve these mathematical problems consumes a lot of power, and the equipment is very expensive. Now, this proof of work is very different than proof of stake networks. So in a proof of stake blockchain network, you still have a transaction that is submitted to the blockchain network, and a transaction fee occurs, or a gas fee. But in this case, we don't have miners, but we have validators. And the way that these validators are chosen to transact or to validate the network is all completely random. So it is random, but there is something called staking. Now, staking is where you stake cryptocurrency, or you pool it together, and based on the number of staked coins, that validator has a higher likelihood of being chosen to validate the network. So think of this like a lottery system. A lottery is completely random, and who gets selected is all random. But if you own more lottery tickets, your likelihood of winning the lottery is higher than somebody with just one lottery ticket. So proof of stake and staking is the same way. So the pools, the validators with the highest cryptocurrency staked have a higher likelihood of being chosen to validate and verify the network. And once again, if they are chosen, they are rewarded with a block reward of cryptocurrency. So there are two ways that a blockchain network actually works to verify and validate transactions and add blocks to the blockchain: proof of work and proof of stake. So the next term on our buzzword bingo card for today is smart contracts. So smart contracts are like what they sound like. They are contracts that actually exist on the blockchain. Now, essentially, they are pieces of code that run a if this then that statement. And they will run and they will execute when preconditions are met based off of that if then statement. Now, the great thing about smart contracts is, again, there's no middleman reviewing the agreement in the contract like a normal paper contract that you may have today to purchase a home, for example. There would be lawyers involved and third parties and lots of eyes on that contract looking through to make sure that the agreements are met based on what is in that contract and what the two parties agreed to. With a smart contract on the blockchain, it's all programmatically done automatically. So as long as the two parties that submit a transaction to that contract, they follow the guidelines and the agreement in the contract, it executes right there on the spot. So you don't need a third party to review to make sure that everyone is in agreement. So if we take an example here of purchasing a NFT or non-fungible token, which we'll talk about on another episode. If I purchase an NFT, I agree to pay some amount of cryptocurrency in exchange for that NFT. That smart contract knows how much I need to pay. And if I submit and I transact enough cryptocurrency in exchange, I get that NFT automatically, right? So that concept of a marketplace. That is one way that smart contracts exist, or it's one way that smart contracts are used to help transact across a blockchain. So smart contracts really add that extra layer on top of the blockchain to handle and facilitate those transactions. And when those transactions meet the guidelines of the contract, those historical records again are added as blocks and added into the blockchain. So let's now spend some time really talking about how Web3 and blockchain and smart contracts may apply to the GIS or the geospatial world. Well, if we think about the concepts around Web3, it's really about decentralization. So those same concepts will really start to apply to the GIS world when we take a look at the geospatial apps that exist out there. More of the layers in those maps, more of the components of the application and the underlying infrastructure supporting those spatial apps will start to get more and more decentralized. You'll also start to see some level of spatial data being stored on a blockchain. Now, I don't think that every single piece of spatial data will be written and stored on a blockchain. The amount of transactions and the fees that would occur would probably be too much to put all GIS data, but there are some historical transactional data that would be good to have on the blockchain. A good example of this is around a concept called proof of location, where you want to verify the physical location of something and have a historical record of that. So in the case of supply chain and tracking trains, or tracking goods leaving a facility on a truck, you want to know when that vehicle left, where it is at all times, and compare that information with other GPS data or other temporal data. So all of that historical data can be written to the blockchain and verified very quickly. So supply chain is one area that I think blockchain will have a big role when it comes to leveraging GIS and geospatial technology in the whole area of supply chain and tracking goods. Another area that Web3 and blockchain may be leveraged for GIS is around location validation. So very quickly being able to verify ownership of things like land ownership and parcel records, and being able to update that information. So as you need to update the cadastral or parcels, and then have somebody purchase a new piece of property or land, and then comparing that transaction to previous transactions and who owns that parcel or land today. I think blockchain is going to come in play there, where today you have a lot of third parties with eyes on that, and the process can be very long, where smart contracts and blockchain can start to speed up that whole transaction. Another way that location validation can come into play is like updating the actual GIS data or land-based data as it pertains to like open source community mapping. So if we think of like OpenStreetMap, one issue today with Google Maps is the points of interest you see on the map, let's say a Target store location, those can actually show up more often based on how much Target is paying Google Maps for advertising. So if you are paying them more than Walmart, your Target store is going to show up more frequently than the Walmart store. And that is because that is a very centralized approach to creating these maps, where OpenStreetMap is very community driven and open source. So if I want to update that a new store location is here, it's all community driven and allows for the community to make those changes. So when we think about blockchain and Web3 coming into play here to help verify or validate that, yeah, that is a Target store and we can now add that to the map, it's a new store that was built, you can have the blockchain and some of these other new concepts that we'll talk about later, things like NFTs and DAOs, decentralized autonomous organizations, that can start to approve these map transactions and add these new points of interest and updates to the map without the need for a lot of intervention, but also consensus with everybody on the network. So instead of a centralized entity controlling the map and what you see on the map, it's again being broken up and decentralized, and now you have a lot more community-driven control over what is seen on the map. There's also some other companies out there that are starting to do geospatial things and location-based things in Web3. I'll put some links to those companies. One of them is Foam, the other is XYO. Maybe we'll cover those companies and what they do on some follow-on videos, but check those companies out. They're doing some really interesting things with GIS and Web3 today. So today's episode has been really focused on Web3, blockchain, proof of work, proof of stake, and smart contracts. Like I said, on a follow-on episode, we'll cover more terms on our bingo card. But thank you all for watching today's video. If you enjoyed this content, please like and subscribe and follow our channel. If you've got ideas or ways that you think Web3 and GIS will interact and intertwine, please comment those below. Or if you haven't already, join our Discord and keep that conversation going. But as always, until next time, stay mappy, my friends.